Swayam Prabha. Digital India. Educated India.
Good evening, everybody. So today we will start with profiling with DLProf, and then we will look into the PyTorch catalyst. So far what we have done, so far we have looked into how to make the entire pipeline for training in deep neural networks. So deep learning algorithms that we have developed so far mostly in the domain of classification, but the same pipeline will be followed for other uh, kind of problems also. So, but in TensorBoard in the last class, that whatever we have seen is how we can actually track or how we can see the performance metrics and maybe the graphs for the computational graph for the algorithm and so. But here in DLProf, what we will see is that we will profile the resource usage, the utilization, the recommendation from the profiler. So all these things we will see in DLProf. So this is a new dimension of profiling that we will see today. And data scientists must be aware of such profiling because this will help essentially to improve the training performance in the end. So in today's session, we will see one of such customization which will improve our performance of training module that we will run. Okay, and we will see how much performance gain we are achieving or what are the improvements we are doing. So all these things we will analyze. And also in the next session, we will see the PyTorch catalyst. So this is, as name suggests, it is accelerated framework for PyTorch. This will give you the flexibility uh, uh, to efficiently wrap up everything, whatever you want to do in PyTorch in very simple terms. Okay, so that also we will see. So that way we will get the enhancement of the training modules. So all these things will be very modular, and it will be easy to define the entire pipeline, and also reproducibility will be very high. So we will start with DLProf. So let me. So as I was mentioning, that DLProf will help you to visualize, analyze, and recommend. Okay. So what kind of recommendations that we will see, as well as we will see what kind of profile that are coming from, let's say, the CPU usage, the GPU usage. Also inside the GPUs, what are the cores that are being used, how much time they are being used, and how you can improve the performance. Now, in the framework point of view, this DLProf supports also by TensorFlow. You can work with TensorFlow and DLProf. You can work with PyTorch, TRT, also several libraries supported by it because you need to improve some performance and support some backend as well. So DALI, NCCL, so all these libraries are also supported. So today we will see how to use PyTorch modules to be profiled with the DLProf profile. Okay, and so before that we will need to understand a few things. So basically, what is DLProf? It helps us to understand and improve the performance of the DL pipeline, and mostly the training pipeline, because it will be iterated several times, as you have seen. One loop or several loops will be running based on your target run or target achievement. Now, it will also generate reports, visualize the profiles. Now, DLProf CLI, what it uses the Insight System Profiler. So we will enable this profiler to input the profiling data, and it will make the database. Also, it will correlate the CPU usage and the GPU usage, because they both will be working in tandem, and some data, it will be shared from or accessed from CPU, and it will be shared to your GPU, and GPU will aggregate or train your model depending on the data which is available. So the correlation between the CPU and GPU will be important, and that will directly get the data from here, as well as it provides to track your tensor cores usage. So this is very, very important, because while we are talking about the deep learning modules or deep learning training in particular, so that means tensor cores must be used, right? Because tensor cores are specifically designed for your deep learning computational acceleration, right? So usage of tensor cores, how it is being monitored or how it is being used by your algorithm, that usage detection must be there. So we will see how to track this, as well as so some library that we will be using for enabling tensor core usage. Now, to profile or to see the recommendations, you need to have one recommender system, right? So the expert system provided by DLProf CLI will provide the recommendations. So if, let's say, your tensor cores are underutilized based on the other cores that are being utilized inside your GPU, so this expert recommender system will tell you that these are not utilized, so you can use these libraries to use to enhance the usage, or maybe let's say you have some data bottleneck or memory bottleneck. So what kind of library you can use to remove that or eradicate the bottleneck? So all these expert suggestions that also will be given by the recommended system, and the viewer will essentially uh, help you to visualize profiles, and also you can log the reports and save them for your later analysis. And also, currently, TensorBoard plugin is also available, so you can use TensorBoard as well to see or visualize the profiles. Okay? So either you use the DLProf viewer or you use TensorBoard plugin. Okay? So we will help you to see both, but I mean there will be some instructions to how you can get the profiles in TensorBoard and how you can get the profiles in viewer. So all these things will. Okay, so as I was mentioning that it supports TensorFlow, TensorRT. So for these two frameworks, you do not need any additional code for modification to be used in DLProf. So it will directly profile the program and it will help you to visualize. For PyTorch, you need to activate this module because this NVTX profile will be written. So basically, you will enable first, and then you use your training pipeline or your multi-stage pipeline or whatever you want to use for your deep learning training. Now, as I was mentioning in the previous slide, the CLI will process this with DLProf, and Viewer will help you to visualize. So very simple few lines of code you need to add for PyTorch, but that is very minimal, just one. Okay. Now, in the previous section, I was mentioning that DLProf, the relationship between DLProf and this automatic precision, mixed precision library is very, very intact because of the tensor cores. So the profiler actually tracks the usage or utilization of your tensor cores that are available inside your GPU. So that means you want to have some computations to be offloaded into the tensor cores, and automatic precision library will help you to do that. Okay. So that is why if you are not using automatic mixed precision library, then the tensor cores will be underutilized. So your training layer will have this pipeline. Let's say I have two convolution layers, three convolution layers here, and normalization, pooling, and so on. So all these layers are there from input to output. So this is one forward pass, and this will be iterated several times. Now, what I want to do, I want to convert or scale some of the parameters into some data types that is supported inside the tensor, because all the data types which are, let's say, floating point single precision data type, which are supported in the CUDA course, that are not supported in your tensor course. Okay? So for the tensor course, you need to scale your data which you will use inside your training model to FP16. Okay? So basically, makes precision, you will do the computing. Okay, you will use both the data types inside your training to be able to optimize and also get better results in that way. Right? So some of the data will be processed in let's say rest of the course, and the scaled data, which is FP16, will be run on the tensor. So that is the purpose of your automatic mixed precision library. Now, automatic mixed precision library has two sources. If you are using NVIDIA, so basically you will be using NVIDIA Apex. And for generalized use of mixed precision library, you can use native Pytorch AMP also. So there are two sources you can use. Either you can use NVIDIA Apex or native Pytorch AMP. Okay, so this is going to be interesting because you'll see that most of the computations which will be run on your tensor course, to convert them or to scale them, you will need very minimal code. Okay, so for use of automatic mixed precision library, it is also very easy. But before going into profiler, you need to know certain things to do and to follow, not to follow, because people often spend some resources, because once you start profiling, many resources will be used. Okay? So what to do? Make sure that your code runs without an issue, because you just check it before running into the DL profiler. You just check it whether your training module is working perfectly or not. Just one run will suffice, that without any error it is running. And also you need to make a habit of using profiler when you make changes in it, because each change can replicate or can offer you a cascading effect which will enhance the either the performance, or it can degrade the performance. Okay, so several order of magnitude of your performance can increase or decrease. So how your change in the code helps either increasing or decreasing the performance, that you need to check every time. And this is just one rule. If you know that this is going to increase your performance, that is good. But in several cases, you will see when you are working with a big pipeline, you will see maintaining certain aspects of speed up will not be actually happening as prescribed by the library. So they will say that this library will help you to enhance the performance, but in some cases it will not happen because of the way you have defined the pipeline. And so basically you need to check every time whether each change is giving you either your desired performance gain. And also you need to get familiarized with some arguments in the DLProf which will be provided. And of course, the iteration range, delay, duration, etc. also you need to get familiar, because all these aspects. So basically, iteration range, how this will affect your training, how much duration you are actually spending for making certain modules run. So all these things you need to be, at least in some abstract way, you need to. And of course, should not profile for extended period of time, because you should not train the entire thing to get correct profile for your training, because training module is essentially one iterative process, right? And the same thing will be repeated every time. So few iterations, if you check for your training model, that will give you overall idea that how it is going to perform. You do not need to go through the entire training process for all the epochs or for all the iterations. You do not need to do. So few of iterations will help you understand that when it is going to be, uh, it needs some modifications or needs some update. Real training is repetitive, as I was mentioning, and that is why you need to spend a couple of minutes to profile it, and that will suffice. Also, try to open DLProf database with your TensorBoard or DLProf viewer. Okay? So basically, this the logs will be saved as database, and uh, the recommended systems are TensorBoard and Profiler, so you can use other. Yeah, so it will help to visualize the DLProf event files. So basically, NVIDIA TestBench GPU plugin you need to use. Okay. So let's go to the demo section now to demonstrate the DLProf, how to do that, and then we will come here. Okay, so let me do full screen. So basically, there are two methods to run DLProf. One is through your notebook and through the terminal. So if you have installed any or if you have not installed or if you want to use the DLProf in Jupyter notebook or any other notebook, you can use it. So the method one is essentially the first method, which is used in the notebook. We will not go into details. You can see the same details in the next previous next section as well. So in the method two, we'll discuss about how to use in command line. So basically, you need to make sure that you have access in NGC. You need to create one account for that, and you need to have Docker engine installed. And if you do not have, you can check these comments to install it, and then you can install the container toolkit, and you can start using the check the whether necessary drivers are there or not, and then we install the NVIDIA Docker for the so this is the distribution that we want to make available inside my Docker. So basically, you just install it with this command, and then once it is installed, so basically you need to install this package for your use, and then you restart the Docker, and then you start it and just check the version. So this is the complete installation of your Docker, and check the version. And once it is successfully installed, then using this NGC Docker, then we will start using that. So basically, you need to pull the Docker image. Okay, so this is the NGC Docker container for our usage. So once it is pulled, then you can just run this command to launch the NGC container now. And once container is launched, then you can install the necessary package. So what are the necessary packages for here? So basically, you need to install NVIDIA PyIndex, NVIDIA DLProf with Pytorch. You can use also TensorFlow, as I was mentioning. So here we are using with Pytorch. And also you need to install NVIDIA DLProf viewer, because we are using DLProf viewer to visualize the profiles. Okay? Now, once you have successfully completed up to this, so basically you have installed all the packages. Now you can use your DLProf in the next command. But before that, you need to have the training.py, because the training module that I want to profile using this DLProf or this targeted workspace. Now, once you have this training.py, so basically let's see what is in the training. So training.py is essentially the entire pipeline for training your deep learning models. Now, some of the packages that you have seen so far, because we have used them. So basically, these imports for your Torch Vision that you have seen. Few others that we need, some libraries for images and plots. So NumPy, PIL, and Matplotlib. And also you need to import the NVTX. So because this will enable this stack tracer for the profiles that will generate from PyTorch training run. Okay, so this is the only one line you need to add to be enabled, be profiled from this training one. Okay, so now once we have all the necessary packages imported, you just specify the device. These are as usual, nothing new. So all the PyTorch things: train set, data set, valid data set. So here we are doing training and validation. So we are just using the train loader and valid loader with this number of batch size. Now notice that we have not enabled the number of workers. Okay, so we want to see what happens. Okay, now once you have defined the train loader and data loader, you just you can print some images. You can see. Okay, so these are the things that we want to do before going into the training part. So this is the class where we are defining the model. So this is the model definition, and we are transferring the model to the device. We are defining the optimizer, the criterion for the loss, and then this is the training loop that we have defined. Okay, and with torch.autocad.profiler, now we are starting the profiling or uh, uh, emitting the traces from here, because before that we do not need all this. So for this loop only I need to profile, because this is the loop for your training. Now how many epochs, you just define it. So for, as I was mentioning, you do not need to run the training for all the epochs, just only one single run will suffice, or maybe 2-3 runs. If you want to have some more satisfaction, you can do 2-3 runs of entire loop and you will get the idea. And this is the validation. Okay. So this is the entire training module which I have written. So now we will go to the code. So basically here, to view the results, you need to run DLProf with this training dot. So this is the command to export the traces into your databases. Then once you run that, you will see that you have, so basically what we have done this, we have yeah, so we have mentioned stack function stack equal to true, and it will write all this data into this current directory. And so from the event files, you can see inside the TensorBoard. Okay, and if you have mentioned the targeted files in any elsewhere, you can mention the directory path here. Now, if you are using DLProf, so in our case, we are using DLProf. So the database will be created into the current directory, which is DLProf_DLDB. So deep learning database .sqlite. So this SQLite database has been created, and it is recommended that you open this using DL profile viewer only. Okay, so because all the necessary encoding and decoding is supported in DLProf viewer. So once you open this, open your profiler into DLProf, then you will see the window. Okay? So basically, you can see that this is loaded from your DLProf profiler into your local host, and now this is the dashboard for your profile. So you can see GPU utilization and resource usage breakdown, and total kernel time GPUs in milliseconds, and total core kernel efficiency. So how much percentage of core kernel has been used. So now, as I was mentioning that these are the usage and let's take this resource usage breakdown. So 20% resources were being used from elsewhere, and data loader is using 65.81 percentage of resources. CPU is using 13.23, and your GPU is very narrow, so not using tensor cores, because we have not actually used the AMP library for enabling the tensor cores. Okay. So if you go to the recommended system, so expert system, in the bottom you will see expert system, and here are some recommendations you can see now. So the recommendations are 945 operations were eligible to use tensor core, but are none are using FP16 because you have not used AMP library. So the recommendation is try enabling AMP library for more information improvements. And GPU is underutilized, only 5.5% is profile, that is fine. And also it has recommended that 65.8% of your aggregated run was spent in the data loader, while not simultaneously running the GPU, because it is waiting for the data, because you are not using multiple cores for loading the data, right? So you can either use num cores greater than 0, okay? So these are the recommendations that you are getting, or use NVIDIA DALI, which is the data loader library from NVIDIA itself. So you can use either of them. So we'll see one of them to use. So and also what kind of systems you are using, and what are their versions, and so on and so forth. All the information we get the guidance here. Since average iteration time is 42 milliseconds, this I mean, you cannot see the graph here, but if you run for more time, like duration in seconds, you can see. So if you run in seconds, you will see what are the use of tensor cores, not using tensor cores, how much memory is being used, data loader, IO, CPU. So these are the performance summary you will get, and I want to improve the average iteration time in the end, because with some performance tweaking and introducing the MP library, I want to use the tensor cores, and in the end I want to use, or I want to enhance the average time. So next we will use the train underscore amp.py. So this training module is using now the AMP library, which is from the Apex. So automatic mix precision now we are using from Apex, right? NVIDIA Apex. So you can go to this reference. Okay, so the usual Python imports, and then defining the device, defining the data loader, train loader, and everything is same. Only thing is that you need to define this model and optimizer for your from your AMP, because now the model should be compatible to use the scaled data types, okay? And also optimizer, because optimizer is essentially computing the gradients and then it is being updated with the gradients. So optimizer and model initialization with the AMP, that is important to use AMP library. So we have imported that before, just one more time. So that import was done before. And next we will go to the defining of the criterion, the training loop. Now this is where we are starting the profiler, and then number of epochs we are defining as 1. The same criterion we are keeping to see what kind of improvement we are getting with the profile. Okay. So x.to device, so data we are transferring to your device, levels we are transferring to your device, the modules, and then we are computing the loss. So basically, while computing the loss, we are now scaling the losses and optimized gradients to your AMP library. So basically, now we are using the mixed precision computer. Now the mixed precision computing uses, so basically if you see here, after the scaled loss and optimizer definition, we will just do the backward pass, which will compute the gradients, and then we will update that and initialize them again to 0. So that's the entire pipeline that we have defined now. Okay, so yeah, so this is the entire definition. We just give you one more explanation of this optimization level. Okay? So when we are optimizing, okay, there are several data types that we have mentioned, right? So we mentioned that you can use either AP32, AP16, or mixed of the two. Now, what will be used inside your training? That will be defined by this optimization level inside the initialization. Now, what will be the criterion? I want to have mixed precision computing. So, so there are 4 levels of optimization: O0, O1, O2, O3. Now, O0 is for use. O0 and O3 is without mixed precision. So O0 is with AP32 and O3 is with AP16, and O1 and O2 is with AP32 and AP16. And based on their usage in training, we will have 2 models of mixed precision. Okay, so O1 and O2. So which will be better for your training? That you need to actually analyze by maybe 1 or 2 runs. Okay, so you use one first, then see the profile, and you use O2 and see the profile. Which model of mixed precision computing is helping your case, that you can see from the profile. So that's all about from the profiler, and let's go to the profiles after using the AMP. So after using the AMP, you can see that go to the recommended system. Now it is not saying the previous message, right? So it was showing that tensor cores were not being used. Now tensor cores are being utilized, and it has increased the utilization from 0.5 to 0.6%. So basically, this was just one run, right? Not multiple runs. And data loader has the highest usage. Still, our data loader has highest usage. So still, we have run that without any workers. And that is why you can see here that data loader is using most of the resources, and also tensor cores are being used. So using GPU1, because we are now using tensor cores using the AMP library. So the usage of GPU utilization has been increased, but you can see that average iteration time also have increased, and that is only because your data loader, because of this data loader bottleneck, you are actually increasing the average iteration time, although you are using AMP library. So after introducing the inside your train underscore amp.py. So here now, after introducing the number of workers equal to 4 in the data loader and valid loader, we will see that so this was the profiler after that. So now you will see that data loader is now 13% only, where others and CPU usage has increased. Okay, and now if you see the average iteration time, it has been decreased. I mean, almost half. So just introducing one trick, it has increased the performance by 2 times. And you can see that GPU is underutilized, but it has almost doubled the utilization, because now it is getting data simultaneously. So basically 1.2% is the double of 0.6, which was before. But still we have some bottleneck still, because this is a very small network, and so this is how actually you will try to assess, analyze. After visualizing, you change your code, use some other libraries, what is recommended by your recommended system, and you increase the usage of your tensor cores that are available inside your GPU. So let's go back to our slide now. So that's all about from DLProf we will do it today.